Hi, I want to go over chapter 3, section 3.1. So I go over some of the problems. So this lecture would help you to do your homework assignment. So first is this one. It said you want to graph pair of 5 and 3. So when you have a point on X and Y axis, when we give you a point or a pair, the first number is X and the second number is the Y. And on the X and Y axis, all the positive X's are on this side and negative, they are on the left side. And also here, positive Y are here, negative, 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 negatives are here. So if you have a pair which both points are positive, let's say you have 2 and 3. Both of them are positive. You know, for the positive, you don't have to put a positive sign. So 2 and 3, that means the first number is always X, the second number is Y. So on this one, you find 2 and 3 on the Y-axis. You draw a rectangle here. The point, this point, let's call it point A, that is your point of 2 and 3. So if both points are positive, they fall into the first quadrant. Now let's say you have a point which is -3 and let's say 5, for instance. See, the first one, X is negative and Y is positive. This is a negative for X, horizontal axis. These are negative for X's. So where is -3 here? Is here. And 5 on the Y-axis is this point. So when you draw your line here, this is your, let's say, point B. Now, what if both points are negative? Like you have, let's say, -8 and both negative and -4. Both of them are negative. X and Y both are negative. In that case, you're in this quadrant. So on the negative axis, you find -8. On the Y-axis, on the negative Y-axis, you find -4, and then you create your rectangle. This is the point of, let's call it C. So again, if both X and Y are negative, you use this quadrant, which is quadrant number 3, Q3. Now, let's have a number, let's call it D. This point has positive for X and negative for Y. So positive X's are here and negative Y is here. So when you connect these two, when you have your rectangle, this corner is your D. So please understand that if your X and Y both are positive, you always fall in the first quadrant. If X and Y, X is negative, Y is positive, you're in the second. In the third quadrant, both of them are negative. On the fourth quadrant, X is positive and Y is negative. So like in this problem, where does 5 and 3 fall? 5 and 3 fall somewhere here in the first quadrant, okay? See, like this one, -3.5. minus 3.5 is easier to see it as a decimal sometimes. See, both of them are, both x and y are negative. So where do we fall? Here. See this point? X is minus 3.5 and y is minus 2. Look, x and y both are negative again. So which quadrant? Which quadrant has both negative? The third one, right? See? Minus 2 and minus 2. Sometimes we give you a point here and we ask you to read the coordinates. Like the point is given and we want you to measure x and y. Now this point is on the x-axis and I see that x is -1. But what is the y value here? No y. Y is 0. You see that? Y is 0. See, like if this point is here, let's say the point is here. What is the value of y? 1. But when you get closer, then the y becomes 0. So anytime you see a point lie on this x-axis, it doesn't have any y. For instance, what is the coordinates of this point? This point, what's the coordinates of this point? Does it have any x? No, because it's on y-axis. So x is 0. And what is the y value? 4. What is the coordinates of this point? It lies on x-axis, okay? It is on x-axis, so x is 3, but it doesn't have any y. How about this point? Lie on y-axis. It doesn't have any x. X is 0, and y is -4. So these are intercept. These are the points lie on x and y axis. Like this one, what is the coordinates of this point? X is -3 and y is 0. Now, we give you equations y equal to 5x minus 4. And we are asking the question, we say, are these points belong to that? Means if you, first of all, remember I said the first point is x and in the pair and the second is y. So they are saying is this, they are saying, okay, if x is 0, is value of y -4? Let's try. You take this 0 and you substitute here. See? Yes, this point is correct. Is 0 and -4 a solution? Yes. But it satisfied the equations, right? The second one, when x is -4, when x is -4 and you substitute that in the equations, I came up with negative 24. When x is negative 4, if y is negative 10, no. Y is not negative 10, y is negative 24, okay? So when we give you a pair and ask you to verify whether this belongs to this equation or not, you could either do this or just take x and y and substitute both into the equation to see if both sides are equal or not, okay? So like another way to do this, the first one, we know the first one is x and the second one is y, right? Take these two numbers and substitute here for y. For y, put negative 10. For x, put negative 4. On left side, I have negative 10, and on this side, I have negative 24. See? They don't work. Same thing. You have equation of y equal 2x2. And then you need to remember the linear equations, it has x to power of 1. If power is not 1, is like 2 or above, then it's not linear equation anymore. Linear equation graph is always a straight line. But if you see equation that power is greater than x, like 2 or 3, this is a curve. It's not a straight line. Anyway, here. So 2x2 is not a straight line, but it doesn't matter in this case. In this case, what they want to know is this point 1, 4 work for this or not? Okay, let's see. So here we put, if x equal to 1, I'll take that and substitute for the x here. So y is 2, 1 to power of 2 is 2. So when x is 1, y is 2 is not 4, right? So what's belong to that? No. How about 2 and 8? Is that the solution to that? Again, what you could do is you could just take a 2 and substitute here, or just take this x and y and substitute both into the equation. Y is 8 on this side, x is 2. So you have 2 times 4, and yes, both sides are 8. So then the answer is yes. They're asking you, is y equal 9x? Is that the linear equation or not? Remember, the power of x is 1. Yes, it is linear. Because power of x is 1. And then you could graph it. And how do I graph it? If you want to graph a straight line, minimum of 2 points. These are arbitrary points. You could pick any points here, okay? So let's say x is 0. When you plug 0 here, 9 times 0 is 0. So x is 0, 0. That's 1 point. Okay. So let's say x is 3. Again, these are arbitrary points. You could pick any number and put it here. 0, positive, negative. If I put 3 here, 3 times 9 is 27. 3 and 27 is point here somewhere. It's out of the picture. So. Okay. You could use the negative number, like what about negative 1? When you put negative 1 here, then it's negative 9. So negative 1 and negative 9 is somewhere here. It's always a very good idea to use 3 instead of 2. Because when you're using 3, if all 3 points, lie on one straight line, yet you know your answer is correct. So don't limit yourself to 2 points. 2 points are good to draw the line, but not enough because you need 3 points. So these are arbitrary points. You could always come up with any number here. It doesn't matter. We all come up with the same line. Is the equation of absolute value linear? You have to graph it first, okay? So I draw a table. Again, come up with some arbitrary. I normally use 0. 0 is always a good number to use. So when you put 0 here, the answer is -3. That's 1 point. Then let's say x is 3, for instance. When x is 3, then y is absolute value of 3 minus 3. Anytime you want to move a number out of the absolute value, it has to be positive. This is positive anyway, so it would be 3 minus 3, which is 0. So that's 2 points. Now let's come up with a negative number. Let's say x is -5. Again, these are arbitrary numbers. When you put -5 here, I'll show it right here for you. Absolute value of -5, -3. You want to calculate the value of y. Anytime a number comes out of the absolute value, it has to be positive because absolute value is the distance, miles, feet, you know, it has to be positive. So when you pull the -5 out, you have to change it to the positive. 5 minus 3. So y is 2. Now, which one of these, you know, when you graph this, you see something like x is 0, y is -3. Let's say here is, this is 1 point. X is 3, y is 0. X is -5, y is 2. I'm sorry, okay, let me do it again. X equals 0, y is -3 is right here. X equals 3, y is 0. X equals -5, y is 2. Okay, so when you connect this, you come up with a line like this. See, it's not a linear. A straight line has to be straight. You cannot break like this, okay? All the straight lines are just going straight like that, but not, there is a break. It comes here, but it turns back here. So this is not linear. And which graph is correct? Is probably C, this one. So absolute value graph is not linear. It's not a straight line. Y equal -2x2 is not linear. Why not? Remember, x, the power of x is not 1, it's 2. So it's not linear. And which graph is it? It's always a curve. It has to be one of these two, okay? So to see which one, let's say x equal 0, you put it here. 0 to power of 2, 0 times -2, 0. X equal 1, you put 1 here. So y is -2, 1 to power of 2, which is -2. Let's try -1. This is important. When you try -1, look, y is -2. When you want to substitute negative number for x, always has to come with a parenthesis. Again, anytime you're taking a negative number and you want to substitute that for the x, it has to come with a parenthesis. What is minus 1 to power of 2. Minus 1 to power of 2, when there is a parenthesis around it, means this. So it's 1. See that? This is 1. So all I have is negative 2 times 1, which is negative 2. So 0, 0, 1 and negative 2. So it's probably this. Look, 1 and negative 1. X is 1, y is negative 2. X is 1, y is negative 2. It's probably here somewhere. Negative 1 and negative 2 is here. And so it's this one. See? It is linear. Why? Because the power of x is 1. Linear. And its graph is easy. Look, just come up with some arbitrary numbers. X is 1. You put a 1 here. Minus 5 times that is minus 5. X is 2. Put 2 here. Minus 5 times 2 is minus 10. X is 3. Put here is minus 15. And when you plot this, you come up with a straight line. Okay. So we know it's a straight line because power of x is 1. Is this linear? No. Look, power of x is 3, is not 1. Not linear. And then, again, you come up with some points like x0, y0. They all have that anyway. X is 1. You put 1 here. 1 to power of 3 is 1. Y is 10. Which one has x equal 1 and y equal 10? Well, first of all, it's not this, right? Because this is a straight line. Yeah, it is the curve. It's not linear. So this one is out. And it's not this one because x is 1, y is 10. See, this point is below. It could be this or that one, right? But this one, when x is negative, let's say what happened when x is negative, like x is negative 1. When you put it here, then y is if you take negative 1 and multiply by itself 3 times, the outcome is negative. So this is negative 10. Which one of these two has negative 1 and negative 10? Negative 10 and negative is probably somewhere here. Okay, so the answer is that. Okay, that end of section 3.1.